All right, let's put you in the driver's seat. Imagine you're a senior multi-cloud architect, and you've just been handed a critical mission. You need to build a platform to handle a massive, non-stop stream of data. The choices you make right now, at the very beginning, they're going to be absolutely crucial. So where do you even start?
First things first, let's frame the problem. Think about this for a second. What do smart scooters zipping around a city, the performance metrics from your company's main app, and all the logs spewing from your servers, what on earth do they all have in common?
The answer? They are all cranking out a relentless, non-stop tsunami of time series data. We're talking about IoT devices, application metrics, system logs, all of it creating little data points stamped with a specific moment in time. This isn't just a trickle of data, it's a full-blown flood.
So to build the right solution, we have to really get what we're dealing with. We need to understand the unique DNA of this data. What exactly makes time series data such a special challenge compared to, just regular old customer data in a normal database?
At its core, it's actually incredibly simple. It's just a sequence of measurements where every single one is tied to a specific point in time. You get a timestamp and you get a value. That's pretty much it. But the real challenge, the thing that makes it an architectural puzzle, is what happens when you have billions and billions of these things coming in at once.
And that leads to these key characteristics, the very things that make a time series database different from a standard one. First, time is the primary axis. Everything revolves around the timestamp. Second, new data is almost always just added to the end. It's append-only. You're not going back and changing old records. Third, and this is a big one, your queries are usually scanning across big ranges of time. You're not asking for a single record. You're asking, what was the average for the last month? Try asking a regular SQL database to do that efficiently. You're going to have a bad time. For a time series database, that's what it was born to do. And that makes retention policies, how long you keep the data, super important for managing your costs and performance.
Let's make this really concrete. Just picture a global fleet of smart scooters. Every single second of every single day, each one of those scooters is reporting its exact location and its battery level. Now multiply that by thousands of scooters, 24/7. That is the kind of scale we have to architect for.
Okay, so this fire hose of data brings us, the architects, to our first fundamental decision. And this is a big one. The choice you make here is going to have a huge impact on your platform, your team's sanity, and for sure, your budget.
So how are you going to handle it? That data from all those scooters is flooding in right now. You need somewhere to put it, you need a way to query it, and you need a strategy to manage it without going broke. So, what's your move?
Well, path A is the managed service. Think Amazon TimeStream or Azure Time Series Insights. With this approach, you are effectively handing over all the operational headaches, the scaling, the updates, the backups to your cloud provider. You just focus on sending your data in and getting value out.
Then there's path B, the do-it-yourself route. Here, you're the one spinning up the servers, installing a database like InfluxDB or Prometheus, and managing the whole shebang yourself. This path gives you the ultimate control, but it also means you have the ultimate responsibility.
Okay, so we've got two very different paths. Let's really break this down and put them side by side to look at the trade-offs. This is where the real architectural thinking begins.
And here's the core dilemma laid bare. A managed service gets you to market fast, with very little operational pain. But you give up a lot of control, and that pay-as-you-go cost model can be a silent killer. It sounds great until a sudden spike in data sends your bill through the roof. Self-hosting is the complete opposite. It's slower to get started and a ton more work, but you get maximum control to tune every little thing and potentially optimize your costs way better at a massive scale. And that really brings us to the most important point. There is no single best answer here. A startup with a small team is probably going to lean towards a managed service so they can move fast. But a huge enterprise with a dedicated platform team, they might go self-hosted every time for that fine-grained control and long-term cost saving.
So how do you make the right call for your situation? Let's build a simple, actionable framework to help you guide that decision.
Here it is, your 3-point architect's checklist. Number 1, be brutally honest about your team's expertise. Do you have engineers who are legitimate experts at running complex distributed databases 24/7? Number 2, what's your budget and how big do you think this thing will get? A pay-as-you-go model that's cheap today could be wildly expensive a year from now. And third, how much control do you really need? Do you require some special configuration or plugin that a managed service just won't let you have?
So, you see, this decision isn't just a technical one. It's a strategic one. You have to align the architecture with your team's actual skills, your company's financial reality, and your business goals. If you get this choice wrong, you could end up with a blown budget, a burned-out team, or a platform that just plain fails.
So you've weighed the options, you've made your choice, the foundation is being laid. But remember, just storing the data is only the beginning. The real question, the one that drives this whole thing, is how are you going to query, visualize, and analyze all this data to actually predict when a scooter needs maintenance, or to optimize your app's performance, or to prevent the next big server outage? That is the next great challenge.